we are given gradients n and the points xy, x1, y1, how do you find the equation of a straight line? We know that delta y over delta x, which is equal to y minus y1 over x minus x1 is equal to n. So we have y minus y1 is equal to n x minus n x1. So this is what you just do. Equate the change in y over change in x to be equal to n. You find the equation of the straight line. Now, when 2 points are given, let's say we are given x1, y1 and b, x2, y2. From this, what is the equation of the gradients? y2 minus y1 over x2 minus x1. It will be equal to y minus y2 over x minus x2. It will also be equal to y minus y1 over x minus x1. So, just equating any of these two, you will get the equation of that straight line. Now, let's say we are given gradients n and intercepts. Let's say we are given the one on y-axis, that is 0, y1, or on x-axis, x, x2, 0. If we are given this, either of this, all we just need to do is to say, for this one we say y minus y1 over x minus 0 is equal to gradient n. Or we can say y minus 0 over x minus x2. So any of this will give us our straight line equation. As if we are given just two intercepts, that is the x-intercepts. Right? Let's see. We have like this. Okay, let me cut it like this. Let's say we have x-intercepts. We have x to 0. And here we have y 0, y1. What is the gradient of this line? You can easily find the gradient by saying y1 minus 0 over 0 minus x2. That is our gradient. Will be equal to y minus y1 over x minus 0. We can also see y minus 0 over x minus x2. So any of this mix will give us our straight line equation. It's very easy. Just these ones are to give us figures. That is just our gradient. All other ones is to get our equation. That's all. Now let's look at where we are given the gradient and one intercept. Most times the y-intercept. Let's see, we have like this. C, 0, C. So the equation of the straight line will be y minus c over x minus 0 is equal to n. So y will be equal to mx plus c. So this one is always referred to gradient intercept format pattern. So when you know the intercepts, you know the gradient. You can write out your equation, straight line equation straight. Double intercept format too. When we have double intercept format too, you know where it calls the x-axis and you know where it calls the y-axis. Let's call this OB, AO. So we can say x for this one, b minus 0 over 0 minus a is equal to x y minus b over x minus 0, b minus 0, 0 minus a. So what do we have next? We have xb equals ab minus ay. So xb plus ay is equal to ab. So dividing through by ab, we have x over a plus y over b is equal to 1. That is our, when you have double intercept format. If you are given a straight line and you are asked to find the intercepts on the x and y axis, just convert everything to this format to be equal to 1. The denominator to x is the x intercept, to y is the y intercept. Now this will bring me to getting another equation. Now we have perpendicular distance p from the origin and angle is alpha. Now let's try to find what this place is. This is alpha, this is 90 minus alpha. For this place, we have this place to be 90 minus alpha. So this place too will be alpha. And this place too will be 90 degrees. Let's call this place A, O. This place B, O, B. For this place, you can see this place is the hypotenuse. This place is the opposite. And this place is the adjacent. So P is equal to A cos alpha, adjacent over hypotenuse. Now, P here is the opposite. And this place is the hypotenuse. So P equals to B sine alpha. Now, we know from our double intercept equation that our equation will be x over a plus y over b is equal to 1. A here is p over cos alpha. B is equal to p over sine alpha. Therefore, x over p plus y over p is equal to 1. Then you can say x cos alpha over p plus y sine alpha over p is equal to 1. So at the end of the day, we can see that x cos alpha plus y sine alpha is equal to p. So when we have the angle, the perpendicular from the origin is making it horizontal, and the distance from the origin, the equation will be x cos alpha plus y sin alpha is equal to p. Thank you. Now we have come to conversion of line equation from one form to another. Most of the time we are given the equation in gradient intercept form like this: y equals to mx plus c. In this place, the m is the gradient, where c is the y-intercept. So anytime you have a line equation, you put it in this format for you to get the gradient of the equation, and the gradient will be m, the coefficient of x, while you make the coefficient of y to be single, 1. Now, general equation should be something like this: ax plus bx plus c equals to 0. So what does that mean? You make everything to be on this side, you make the equation to be 0 to turn it to general equation form. Double intercept form, you know, if you have the equation like this, at the end of the day, you just have x over a plus y over b equals to 1. So what are we saying? The answer of this equation should give you 1, and from there you can easily get your a, that is the x-intercept, and b, the y-intercept. Now let's look at another one: distance from origin, the perpendicular distance from origin, and the angular form. The form is always like this: x cos alpha plus y sin alpha is equal to p, that is the perpendicular distance from the origin. I will give you one example now to illustrate this. Let's quickly look at this example. We have 3x minus 6y plus 4 equals to 0. This is general form. Now, to convert it to gradient intercept form, we make y the subject of the formula. And how do we do that? We have it like this: minus 6y is equal to minus 3x minus 4. So y is equal to half x plus 6 over 4 over 6, or 2 over 3. 2 over 3. So this is gradient intercept form. From here you see that the gradient is equal to half, and the y-intercept is equal to 2 over 3. Now let's see. Let's convert it to double intercept form. Double intercept form. Looking at this, you have it to be 3x minus 6y is equal to minus 4. Let's divide 2 by minus 4. Oh. Minus 6y. Let's divide 2 by minus 4. We have 6y over 4 minus 3x over 4 is equal to 1. So, we can see that this one gives us 3 over 2y minus 3 over 4x is equal to 1. So what is our intercept now? You can still go further and say y over 2 over 3 minus x over 4 over 3 is equal to 1. From this, we see that our y-intercept is 2 over 3 and our x-intercept is minus 4 over 3, which equals to 1. You can easily test for this. To find y-intercepts, make x equals to 0. To find x-intercepts, make y equal to 0. And from there, you can find y, you can find x. You will see, it will give you y-intercept to be 2/3, x-intercept to be -4/3. Now, let us see if you can get it in this distance from the origin format. Which means that we have y all over 2/3 minus x all over 4/3 equals to 1. It means that y into 3, okay, now to get the distance from origin form for this, I want to make a foundational explanation. When we have straight general equation like this, the way to convert it to this form is to make it ax plus by plus c over root a square plus b square, a square plus b square, a square plus b square equals to 0. So you have x to a over root of a square plus b square plus y into b over root of a square plus b square is equal to minus c over root of a square plus b square. Now, here we can see that a over root of a square plus b square is cos alpha. B over root of a square plus b square is equal to sine alpha. So with this, we can easily get our equation straight. Now, if I want to convert this one to that format, I just make it like this: 3x over root of 3 square plus 6 square. Since the denominator is equal all through, I make it like this: minus 6y plus 4 equals 0. So I'm going to have this 36, 9. So I'm going to have 3x over root of 45 minus 6y over root of 45 is equal to minus 4 over root of 45. Please, I want to call your attention to something which I did not explain initially. Root of 45 can be positive or negative. So we take the one that corresponds to this sign here, so that our p will be positive. So it's going to be, for this one, I rather take minus. So minus, minus. So at the end of the day, I'm going to have it like this: 6y over root 45 minus 3x over root 45 is going to give me 4 over root 45. So at the end of the day, that's what we are going to have. Thank you. Now let's talk about intersection of two lines. Two lines will intersect when there is a common point to the two lines. How do I mean? Let's say we have a line n x plus c is equal to y. Another line, n2x plus d is equal to y. And let's call this one line 2. If this is line 1 and this is line 2, it means that this point of intersection, they will meet at a point which satisfies this equation and satisfies this equation at the same time. So how do you find this point? We solve using our simultaneous equation knowledge. That's how we solve it. You can solve using substitution, you can solve using elimination, you can solve using matrices, determinants, whatever format. So when you bring the point of intersection is the solution to the two simultaneous equations. That's how you solve it. Now we have to find the distance from the origin to a straight line. How do you go about it? We are talking about the perpendicular distance from the origin. Let's say this is the origin. This is the distance. The distance is P. Let's make this place 0. O, A, B, and C. And our equation for the straight line is AX plus BY plus C equals 0. So the intercept on x-axis will be minus C over A. The intercept on the y-axis will be minus C over B. And the distance from A to C, that is the distance of the intercept, the length of the intercept will be square root of minus C over A squared plus minus C over B squared. Fine. The angle subtended with the x-axis is alpha. Therefore, angle OCB will be equal to 90 minus alpha. Here, this angle AOB will be 90 minus alpha. So this is perpendicular. On closer observation, you see that this place is 90 degrees. So this place also will be alpha. Now let's take it one after the other. The distance AC will be equal to square root of minus C over A squared plus minus C over B squared, which will give me C over AB square root of A squared plus B squared. That's AC. And you can see for triangle OBC, angle alpha here, if you are to consider the angle alpha here, OB is going to be the adjacent and OC is going to be the hypotenuse. Therefore, OB over OC is going to be cos alpha. Then that means P over OC. P is equal to OC cos alpha. Yeah, let me state it straight. OC cos alpha. At the same time, P, if you look at triangle OAOB, P is the opposite, while AO is the hypotenuse. So P is equal to OA sine alpha. Now, looking at triangle AOC, we can see that cos alpha is also equal to A cos alpha is equal to OA over AC. Now, we can find our P with ease. P is equal to, what is OC? Minus C over A. What is cos alpha? Is equal to OA. What is our OA? That is minus C over B. And what is AC? AC is equal to C over AB roots A squared plus B squared. So this one here represents the cos alpha. Looking at it further, you will realize that P is going to be minus C over A times minus C over B times AB over C square root A squared plus B squared. Let me make it brighter. P equals to minus C over A times minus C over B times AB over C. C roots, sorry, this one should be roots A squared plus B squared. So cutting this one becomes, so this one becomes positive. So this one causes this one causes this. So at the end of the day, I have P equals to C over square root of A squared plus B squared. This one will be positive or negative depending on the sign of C, depending on the sign that precedes C. So if the sign is negative, you pick negative. If the sign is positive, you pick positive. So at the end of the day, because it is distance, P should be equal to C over square root of A squared plus B squared. So for other functions that you are going to perform, that is what will determine the sign of the denominator. But if you are just to find the distance, it will be positive. Thank you. Now let's get distance from a point to a straight line. Let's assume I have a point H with coordinates x1, y1. And I want to find the distance from this line, from this point to line ax plus by plus c. Let's see how I can go about it. I draw a parallel line to P here from H, and I draw a parallel line to line ax plus by plus c here. So I have a parallelogram there, and that's it. From here also, I can draw a line down and draw this line, parallel line to P, a bit down. Yeah. From here, let me draw another parallel line. From this point, x1, let me draw another parallel line to P. So, the parallel line to P is now extended. Here, I have x1 here. I have y1 here. y1. Here is O. Here is minus C over A. Here is minus C over B. And before, we got our sine and our cosine. Looking at this very well, this place will be alpha, this place will be 90 minus alpha. Automatically, this place too will be alpha. Please get it. This place will be 90 minus alpha. And since this is perpendicular to this line, this place too will be alpha. Now let's look at it. I have OP x1. This place I can now break into like 3. Let's say this place is OF. This place is G. So OF now, let me call this place. Looking at it, you see that OF will be equal to x1 cos alpha. And here, I have a parallel line to FG. Let me call this place H. Okay, that is H. Yes, H. HI. Let me call it HI. So, IH will be equal to PG. FG, sorry. IH will be equal to FG. P is the total distance from here to here, please. P is the total distance O to C. Here, let me make it. O, P. So that's the total distance, P. So, from I to H, looking at this triangle here, you will see that y1 is the hypotenuse and IH is the opposite. It will be y1 sine alpha. And here, IH is equal to FG. You can see that IH is equal to FG straight. The distance from this line, from this point to line, is also equal to the distance from G to P here. To P. So, let's call this place D. So D will be equal to P minus OG, which is equal to P minus OF plus FG. What is our cos alpha? Our cos alpha is minus C over B divided by the hypotenuse here, that is square root of minus C over A all squared plus minus C over B all squared, which gives, that's cos alpha. So, and our sine alpha is also equal to minus C over A now. OF, as we got initially, is going to be x1 cos alpha, and IH is y1 sin alpha. I'm trying to make it straightforward. So, our hypotenuse is already equal to, let me get it straight, C over AB into square root of A squared plus B squared. Cos alpha is equal to plus B squared and sine alpha minus b over square root of a squared plus b squared. That one is already got. So we can now walk straight. We said that d equals to p minus og, which is p minus of minus plus fg brackets. We knew our p from the last section that p equals to c over square root of a squared plus b squared. Therefore, our OF now, OF will be equal to, we said x1 to this, so minus ax1 over square root of a squared plus b squared. And what is our FG? Our FG is equal to IH, which is equal to y1 sine alpha minus b y1 over square root of a squared plus b squared. So p is minus c over square root of a squared plus b squared. OF is minus a into x1 over square root of a squared plus b squared. FG is minus b into y1 over square root of a squared plus b squared. Now, we are going to subtract the sum of this from this. And what our answer is going to be is this. So d from a point is going to be c, since they all have the same denominator, a squared plus b squared, minus OF is minus ax1, FG is minus by1. So d, the distance is now going to be c plus ax1 plus by1 over square root of a squared plus b squared, which is equal to ax1 plus by1 plus c over square root of a squared plus b squared. As explained before, the sign here will determine the one you pick here. If the sign before c is negative, you pick minus a squared plus b squared. So that's what determines. So this is the formula for the distance from a point. All you need to do is to substitute the x components with x1 and the y components with y1, and divide all through by the sum of the square of coefficient of x and square of coefficient of y. So the square root of this. So that's the answer. Now, another way you can look at it is this. Let's say we have a point H here with x1, y1 as its coordinates. I want to find the distance from this point to our straight line here. Another way you can look at this is just draw a parallel line. And the parallel line will just go like this. What will be the equation of this parallel line? From our initial section, we have discovered how to get the equation of this parallel line. We have x1, y1 as our coordinates. So the equation of this line here, as we said, it will be equal to ax plus by is equal to ax1 plus by1. So the equation will now be in general form ax plus by minus ax1 plus by1 is equal to 0. That is the equation for this line now. The distance from origin to ax plus by plus c equals to 0. That one will be p. Let's call this one p is equal to c over square root of a squared plus b squared. you can see that the coefficient of x and y is still the same thing with this one since they are parallel. Let's now call the distance from here to here. Let's call it q. So q will be equal to minus ax1 plus by1 all over square root of a squared plus b squared. D, the distance between these two from here to here. D will be equal to P minus Q. So D will be equal to, since they have the same coefficients, a squared, b squared, C minus a x1 plus b y1. Therefore, the distance from a point to another line is going to be c plus, because this one and this one will multiply each other, ax1 plus by1 over square root of a squared plus b squared, which is equal to ax1 plus by1 plus c over square root of a squared plus b squared. Thank you. We are talking about concurrent points now. When three or more lines intersect at a point, the lines are said to be concurrent. That is, the point fits in the equation of the three lines. For example, when we have equation a1x plus b1y plus c1 equals 0, a2x plus b2y plus c2 equals 0, a3x plus b3y plus c3 equals 0, and point x1, y1, if substituted or gotten through simultaneous solution of any of the two equations, that is, you use simultaneous equation to find the point of intersection of any of the two, and later substitute into the third equation, and it is a solution. When substituted into the third equation, they are concurrent. That is, they all meet at that point. Now, we are talking about some concurrent points in a triangle. We have like 4, and I will take them in turns. Starting with centroid. Centroid is point of concurrency or intersection of all the median of the triangle. It always lies inside the periphery of the triangle, lies on the medians, and divides them in the ratio 2:1. What do we mean by centroid? This one will be appreciated much by those who work with differentiation and integration to find the centroid. It's one aspect in mechanics. Now let's look at it. We have a triangle like this, A, B, and C, and then the center is dotted by this one cut in here equally, that is median is cutting this one equally, this one too equally, and this one too. If you cut this one equally, then make this one 1, 1. So this one will be 3, 3. So what we are saying now is it lies inside, and this point D will be equal to 2/3 of this place to this place. 2/3 of this place to this place. So this one will be 2/3 of this place to this place. So if you know the A to be x1, y1, B, x2, y2, C, x3, y3. D can be gotten as x1 plus x2 plus x3 over 3, y1 plus y2 plus y3 over 3. That's how you get the centroid of a triangle. It's very important that we have the knowledge of this in solution of some problems. The proof of this will be done in the word examples section. Now let's talk about the circumcenter. This is the point of concurrency or intersection of all the perpendicular bisectors of the sides of the triangle. It may be inside, outside, or on the line, that is on the hypotenuse in case of right angle triangle, and does not divide the perpendicular bisector in any given fixed ratio. You know, in that of centroid, it divides the line in the ratio 2:1. But here, there is no fixed ratio for it. This one will be appreciated by those who have been involved in drawing of circle around the triangle. Now let's look at what we mean by circumcenter. Let's say we have A, we have B, we have C. If you want to find the center of a circle that will touch all the points A, B, C, that is what we call the circumcenter. Now, we find it by doing this one will be equal to this. You see that the difference between this one and the other one, and that of the circumcenter, is that this one divides the line perpendicularly. The angle here is perpendicular. But the other one, it just divides it and touches the apex. Now, and this one too will come like this. It must divide this place. So there is no formula or say, oh, it will be ratio this to this. So that's how we get the circumcenter. So you might be given any point. So all you need to do to find the circumcenter, find the equation of the perpendicular bisector. The point of intersection of the perpendicular bisector is the circumcenter. And then from here, for you to find the radius, just find the distance from here to any of these teeth. And that's all. Now let's talk about the incenter. Incenter is a point of intersection of all the bisectors of internal angle of the triangle. Always lie inside the periphery of the triangle and does not divide the angle bisector in any fixed ratio. If you have done locus before, you probably might have put circle inside a fixed triangle. I mean like this. Second circle is the one outside. This circle is the one inside, touching the edges of the triangle. But second circle touch the vertices of the triangle. So what we are saying now is the center of that triangle is the incenter. And how do we now find the incenter? By bisecting. Okay, let me first of all give this ABC. So we bisect this. The angle here will be equal to the angle here. So we bisect this one too. The angle here becomes the angle, so it will be equal to the angle here. So this one too, we bisect this one too. This one. So the angles here will be equal to. So the point of intersection here, and we know from our construction, geometry, the perpendicular distance from here will be equal. So at the end of the day, the distance here will all be equal. And this point here, from here, this place, the perpendicular distance from here to this place, or any place, will be the radius of the in circle. So that's why we call it incenter. So please, I want you to know the difference. The first one divides the sides by 2, but it's not perpendicular bisector. For the circumcenter is the perpendicular bisector. For the incenter, it is the bisector of the angles, and the point of intersection of the bisector is the incenter. Now let's talk about the orthocenter. It is the point of intersection of all the altitudes of the triangle. may be inside or outside of the triangle and does not divide the altitude in any fixed ratio. Now let's look at what we mean. We have a triangle A, B, and C. So altitude is the perpendicular distance from this line to the next vertex or vertex. Here, let's look at it. So this is it, the perpendicular distance. So it does not divide this line. There is no rule about how you should divide this line in any ratio. All we know is from this place to this place is perpendicular to each other. The same way, this one goes like this. So this one too will go like this and form this. So that is what we mean by orthocenter. The point of intersection of the altitude from any of the vertices to the base. If you know this one and you know this one, you can easily find the area of the triangle. So that is how the knowledge of all these concurrent points in a triangle will assist in solving some locus problem in our straight line equation. Thank you very much. Please remember to like, subscribe, and share. I believe we have been able to exchange certain knowledge, and in future we will do more. Your comments will be appreciated, and your input, whatever advice you give, will also be appreciated. Thank you very much.